Hello everyone. This video would focus on simplifying radical expressions by rationalizing the denominator, and this is the first part. Before we go further, please feel free to check out the description box below for the link of the other series of topics related to radical expressions. Before we jump into these two examples right here, let's have a review on the parts and definition of radical expressions. Please remember that these are the parts of every radical expression. The first part is the radical symbol. The reason why this is called radical expression is because it is an expression that contains the radical symbol. Our A here is called a coefficient. A coefficient is a number multiplied to the radical expression. And the letter N here is called the index. This tells you which root you're looking for. Please remember that if the value of the index is not written in there, it means that that invisible number is 2. We also have a letter C, and this letter C is named as the radicand. A radicand is the value that you are taking the root of. So this expression that we have here is read as A times the nth root of C. So this is read as square root of 36. So if we wanted to know what is the value of square root of 36, we can go ahead and equal this whole expression to x. So this is read as square root of 36 equals x. Now we are going to rewrite this into its equivalent exponential form. This expression or this equation that we have here means that x squared is equal to 36. What is x? So if you notice, our x here becomes the base of the exponential form, while our index of 2, which is invisible, becomes the exponent in the exponential form, and our radicand, which is 36, will become the answer to the exponential expression. What we're trying to do right now is we're supposed to determine the value of x such that when we multiply this x by itself twice, it will give us 36. Meaning if we have blank times blank equals 36, and it should be the same number. So then these two numbers would be 6 times 6. So 6 times 6 is 36. And so we can go ahead and rewrite this as 6 squared equals 36. And so this tells us that our x is 6. So then this square root of 36 then will equal to 6. So that's how we evaluate radical expression. So these are the parts and definition of radical expressions. By definition, rationalizing the denominator means getting rid of the radicals in the denominator, or radicals in the denominators are eliminated. Okay, so let's look at this first example here. We are given the square root of this fraction 4 over 9. Now we remember that if a fraction is inside a radical symbol, this means that both the numerator and the denominator have radicals on them, so that we can go ahead and rewrite this as the square root of 4 over the square root of 9. So that is one of the properties of radicals. Now we are going to simplify both the numerator and the denominator, because we remember that the general rule in simplifying radical expression is that there should be no radicals in the denominator. So we have a square root of 9 in the denominator here. But then we can go ahead and simplify this further. The square root of 4 is basically 2. And then the square root of 9 is 3. Now notice that in this final answer, we don't have a radical in the denominator, which is, again, the basic rule in simplifying radical expressions. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Since we already have radicals for both numerator and denominator, which is pretty much similar to that of the first example, we can go ahead and just simplify them. Square root of 36 is 6, and the square root of 25 is 5. So this is the simplified version of this expression that we have on this left side right here. Now again, notice that there is no radical in the denominator, and then again, that is the basic rule in simplifying radicals. There should be no radicals in the denominator. Now let's move on to the next example. Okay, in this next example, we have a square root of 5 divided by 3 square root of 2. Again, the general rule in simplifying radicals is that there should be no radicals in the denominator. If you notice, there's a square root of 2 in the denominator. So we go ahead and take that square root of 2 out from the denominator, and that would be the simplified version of this radical expression. So this is what we're going to do. I'm going to go ahead and rewrite this expression on the side right here. So that is square root of 5 over 3 square root of 2. So what we would do here is that we are going to multiply whatever's in the denominator. So then we can go ahead and say that we can multiply this by 3 square root of 2 over 3 square root of 2. Whatever is in the denominator, just multiply them. And if you notice, this is 1 right here. So we're pretty much multiplying 1. We're not actually changing the whole equation. We're just multiplying it by 1. Anything multiplied by 1 is just the same number. So that we can go ahead and simplify this further. This will come out. There's an invisible 1 right here. So 1 times 3 is 3. And then we have 5 times 2 is 10. And that is under the radical symbol. And then that is over 3 times 3 is 9. And then 2 times 2 is 4. And then again, that's under the radical symbol. So that is 4. So that we can go ahead and simplify this further. This will come out 3. So the top will be 3 square root of 10 over 9 times the square root of 4 is 2. So that we can go ahead and say that this is 3 square root of 10 over 9 times 2 is 18. Since these two are still divisible to each other, we can go ahead and simplify this further. There is 1 3 in 3, and there are 6 3 in 18. So that we can go ahead and say that the final answer, or the simplified version for this, would be 1 square root of 10 over 6, but we don't have to write the 1. So we can go ahead and rewrite this as square root of 10 over 6. So this is the simplified version of this expression that we have up there. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, we are going to rewrite this expression on the side here. Now, since there is a radical in the denominator, again, the rule is that there should be no radical in the denominator, and that is the simplified version of a radical expression. So then we go ahead and multiply this expression, both the top and then the bottom, or the numerator and the denominator, with 5 square root of 7. So I go ahead and multiply that by 5 square root of 7 over 5 square root of 7. So I'm pretty much multiplying 1 to this expression that we have here. So that we can go ahead and simplify this as that's gonna be, now in this case right here, we're supposed to use the distributive property. So we are going to multiply this expression to the first, so that this would come out. So I'm going to show the work on the side right here. So multiplying the 5 square root of 7 to the second term, this is what it came out. So 5 square root of 7 times negative square root of 3. And then we also have multiplied 5 times 5, that came out 25. Square root of 7 times square root of 7 is square root of 49. So that we can go ahead and multiply them together. So this would be 5 times 2 is 10. So I'm just going to go ahead and write that down here. So that is 10. Square root of 7 times square root of 5 is square root of 35. And then we have 5 times negative 1 is negative 5. And then square root of 7 times square root of 3 is square root of 21. So that we simplify this further, we have a 25. And then times the square root of 49 is 7. So then this will come out to be, that's gonna be 10 square root of 35 minus 5 square root of 21 over 25 times 7 is 175. So if you notice, there is no radical in the denominator. And so this is the simplified version of this expression that we have up there. Did you get the same answers as this? Good. Perfect. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so again, we are supposed to simplify this. There is a radical in the denominator, so we go ahead and remember that if we say a simplified radical expression, there should be no radical in the denominator. So we go ahead and rewrite this expression and multiply both the numerator and the denominator with 2 square root of 7. So this is how it's gonna look like. Okay, so what I did was I multiplied whatever's in the denominator, 2 square root of 7, I multiplied it to both the numerator and the denominator. And then we go ahead and distribute this 2 square root of 7 to each of the terms to the other, to the left side right here. And so we go ahead and rewrite this as So what we do next is we are going to simplify this and simplify the denominator as well. And this is how it's going to look like. So what I did here was that I multiplied 2 times negative 3 is negative 6. And then we have a square root of 7. And then we have 2 times 1 is 2. Square root of 7 times square root of 5 is square root of 35. And then 4 times the square root of 49 is 7. We multiply them. That's 28. And so this is the simplified version of this expression that we have up there. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!